Hi guys, welcome back to the channel. Today we will continue with the part 2 of What a Wonderful Machine. With the help of two friends that are both electronic engineer, Alberto and Lucio, we will retrofit the existing enclosure, because in this way doesn't work for the VFD. This one is an imported VFD, is an ET1. We will practically work on the external port for the signal to the switch. We will try to keep the existing switch method, and for these reasons Alberto practically developed a system, and Lucio build up the PCB board, and we will see if will work and if everything will run in the proper way. And after we will set all the required function to the VFD for to give the prompt to the control buttons. We have to remember that this machine is a drilling machine here and is a tapping machine. The power tapping is possible thanks to these two limit switch here. Practically with this nut we will set the high of our roll. Let's say that this is 0, okay, and we want to go down 20 millimeter. We tight this screw, and now it's going down only 20 millimeter. As you can see here, we have this limit, mechanic limit. So when I start to push down, the first limit switch will power on, and will give the forward direction to the machine. When the second limit switch will reach the limit here, the machine is ready to make the reverse. So when I will reverse the rotation of the handle, the machine in automatic will start to reverse. In this way, the power tapping is working through limit switch. We will place here a nice potentiometer. The pot is this one. I use also for some other machine, and it's very good, you know. Nothing to say. Here we have to make now the hole. I should make an hole of 7 millimeter. And it's funny, this is also the first time that we will use the drill press, you know. I placed this new inverter. Is always 3-phase 220, but work much better than the other one. I also add this switch. And now we will fix here the potentiometer. Look. Voilà. That this will be sealed. Nice. Yeah, you can feel that. Okay, we are ready to make the first hole on the metal. Wow. totally different story than the other one. And now we have to fix these pins on the enclosure cover. I will use M3, and this will go here in this way, and here we will have the pot control. Like this. And here I need to make an hole in order to pass through the cable. Let's do it off camera. Now we will put the potentiometer and the pedal switch in order to give run and stop. But will not be run and stop, but practically will be like enable and disable, because we will control at the moment the drill press with this original enclosure and connection. For the moment, let's leave it like this. And now we have to choose 3 cable, and we will choose pass through here, that one, and 3. Now here we have to, this is the things, is ready, that one. I'm not very good on soldering, you know. Okay, one is done. Now we have to make the other one. Come on, is here. Okay, now nice, this one. And now the third one. Let's do the same here. Okay. We have here our connection. Beautiful. In pink is 5 volts. Nice. Okay. Nice. And we have our pots. Practically now I will put the pedal switching, enable and disable. To do it we have to go to program, P53, because it's in X4, P53, and we will place P11, 11. Okay, now we have to make a P11 external port 2, and now should work. Yes. Enable and disable. Enable disable. In this moment the inverter is driving everything through the machine control panel, but in truth this is not good, you know. It's working 100% as you can see, and is working for each operation. Now we have also a very important issue here. In this moment, you know, if we act on the potentiometer, because this is 220 3-phase and the motor is 380 2-phase, here at the transformer we have a problem, you know, because each time that we change the frequency from 50 Hz, for instance, to 10 Hz, in order to manage a different kind of speed, the transformer from 24 volts will receive less current. And this means that because I put down here at 20 Hz, also the transformer will not give any more 24 volts. And here we have the contactor. This contactor works at 24 volts. And of course there is, let's say, a gap. Maybe the contactor will work until they receive maybe 20 volts, but less than 20 volts. The contactor will shut off. So now, in what way we can manage here the situation? There is only one option, is to give to the transformer a direct 220 line. Like this, the transformer will be more stable, will always supply to the contactor 24 volts and no more up and down, up the frequency that we manage from the pot. So let's do all of this work. Okay, as you can see here, now I remove from the machine the enclosure, because here we have to put this 24 volts transformer. So now let's one and two. There is always something. Okay. At least now we can see and we can work a little bit better here. I cut here. Red, one is going in L3, 0 red, 1 0 volt, T3. I don't know if I want to, maybe the best thing is to do it in this way. Let's cut also this one. Let's put back. Because in this way it's more easy to manage, you know. 1 and 2 are cut. And now 400 volts. 400 volts go to line 1. Okay, and now I cut also this cable here. Nice. And now at this stage I will cut also this one, and the original 400 volts 24 volts things is free. Here I have opposite cable. This one is 220 and the red is 24. Okay, and this is done. Okay, and let's say 220. Okay, and this is 0. Okay, I make the connection, and now I will put also this one. I'm happy because in this way everything is quite nice. Now let's put back this one here. Okay, at least this is in, nice and solid. And now we have to remove this one from here. Is disconnected, so no, it's not dangerous. Also discharge the capacitor inside, and this one we go here. 1, 2, 3, 4, and we will put back those things here. And this one here is the original setup that now we will replicate here. Okay, and now U is here. Nice, is inside, nice and tight. And now let's put the ground here. It's a little bit. Okay, and it's fixed. 1 and 2. And now this one will go back. Let's, but it's not working. It's not working. Now with the voltmeter we will try to check if there is a power. 0. How can be possible that? Should not. I don't know. I solved the issue. From dramatic go to grotesque. You know what was the problem? I thought that this safety switch was abnormally open. Thanks God that I think about this detail, because I was driving crazy, you know. So, but now finally is working. We can try the power drill in drilling and on tapping. Thanks to my friend, we make this board that is drilling and tapping. That was done for his milling machine, and in his milling machine is working. Here not, because one channel will remain open and will not switch off. So this means that to do it we have to modify this PCB. At the end we decide to develop an Arduino code and to drive the VFD through Arduino. And the code is almost done. My friend Lucio is working on this, and I hope soon that we can try on the drilling machine. Let's switch on the machine, and we can control with the pedal switch. Practically the pedal switch will give enable and disable. You know, if I press the pedal, the VFD is enabled now. As you can see here, we have the pot. I can push to 65 Hz. Let's try in this way. In Italy we have 50 Hz in truth. This engine is 50 Hz. But I can push, we believe that I can push a little bit further, you know. So now, with this selector, we will do forward drilling, and here we can control the speed. In this moment, we are going at 600 RPM, and we will try to make the first hole. It's too fast for our hole. Let's try again. Drilling. Okay. I want to. Okay. Okay. Tapping. Okay. Let's try. Okay. And our first step is done. And it's nice. Okay. Nice. Now let's put the top. Nice. And we can go. Reverse. And stop. Over here. Nice and straight and fast, you know? Over there. So guys, thank you for watching me. If you like the video, please put a like, and if you didn't, please subscribe. See you the next one.